HPE's position in quantum computing is to build a practical quantum supercomputer at a scale by tight integration with high-performance computing and networking. There are significant challenges to scale quantum computers from existing machines around hundreds of qubits to millions of qubits. And these challenges are related to real-time control, real-time error correction, workload management, and discovering new quantum applications. Tight quantum HPC integration is essential, and it's timely, it's necessary to enable quantum computers to tackle practical problems. And these are related to scientific computing, which you need high precision calculations. The way we are going to do that is to look at the various different space-time trade-offs, having a co-design approach to build software and hardware from a systems engineering perspective. It's a holistic approach to quantum computing, looking at application development environment, how to distribute job over heterogeneous system, and invoke quantum computers when it matters.
Networks are extremely important for quantum computers, and there are various different layers of networks that are important. Here at Hewlett Packard Labs, we're using a new algorithmic approach to quantum networking, and this is using what we call adaptive circuit knitting. We believe that as we scale from thousands to millions of qubit, networking is going to be a key performance bottleneck. And so it's very important to tune the networks so that they can provide the best performance for quantum computers.
We already know what we use the most powerful supercomputers in the world for. Exascale machines are constantly being used to simulate material science problems, drug discovery, quantum chemistry, and we believe that bringing quantum computers in the game will solve the next generation of these problems to the next level of accuracy and overall improve our ability to solve these hard problems. What we would like to provide is that we're thinking about, okay, this is the application you're interested in. So this is the HPC that you should pre-optimize on. This is the QC system that you should be running it on. This is the hardware. This is the error correction code. This is the number of shots you need. And we want to do all those things for you by bringing in the best algorithms that we have and the best hardware we have. Distributed systems are tricky. They are very powerful, but then you have to deal with small issues like synchronization. But there is also an opportunity here, which is that for quantum algorithms, if you want to divide them on many different QPUs, you have to kind of partition them in a clever way while thinking about entanglement, overhead, and so on. So those are the things we like to think about.
HPE has lots of customers in the high-performance computing business, and those customers we've seen are using HPC for a lot of quantum simulation, involving chemistry, quantum chemistry, materials design. What we're looking at right now is how do we help those customers adopt and integrate these quantum technologies. Benchmarking is a key part of the product strategy in that we are thinking about benchmarking because all of our customers care about performance. When we think about benchmarking, we want to be able to test our systems as part of a DevOps cycle, but we also want to be able to monitor how performance is working on a given workflow to ensure that we are improving the technology at the right parts of the stack. So it's an integrated part of our development as well as our operations. The thing that distinguishes HPE's quantum approach to others is twofold. One is we're working on a distributed quantum computing architecture that is agnostic to the architecture modality from the quantum side, but we also have high integration, tight integration with modern computing architectures involving CPUs, GPUs, FPGAs, probabilistic programming units, and we want to be able to work together with these architectures to scale these quantum architectures out to utility scale.
We believe that there is going to be significant changes in how we do compute. High-performance computing would be completely transformed from forces from both AI and quantum. And the combination of AI and HPC over the next decade would enable quantum computers to become available and relevant for practical applications.